All right, so in the notes for today for A2, we're going to be looking at some problems that involve using just general number sense to answer them. Starting off here, the definition of a rate. A rate is a ratio between two related quantities that's measured in different units. And so in the first example, we're given the formula for speed. So speed is defined as being rate is equal to distance divided by time. The problem says that if distance is being measured in kilometers and if time is being measured in hours, what is an appropriate measurement unit for the rate of speed? So we're given the equation rate is equal to distance divided by time, and then distance is being measured in kilometers and time is being measured in hours. And so an appropriate measurement unit for the rate of speed would be kilometers per hour. So for this question, there's no number crunching that you have to do. You're not trying to solve for something. You're just trying to say what the units would be if you were going to be solving a problem like this. All right, down here in this next example, we have the definition that a unit rate is when a quantity is compared to a single unit quantity. And so another way of thinking about a unit rate is it's when you figure out how much one of them would cost. So in this first example, it says if 8 apples costs $2.96, what is the price per apple? So you're trying to figure out how much one apple costs. And so if the rate is that $2.96 would buy you 8 apples, we can calculate that division. So $2.96 divided by 8. And so that would give you 37 cents per apple. So each one apple would cost 37 cents. In the next example, it says Joe claims that 6 bagels for $3.15 is a better deal than 8 bagels for $4.15. And you want to figure out if he's correct or not. So a better deal would mean that in the first example, the bagels would be less expensive than in the second example. In order to compare them, we want to figure out the unit rate per bagel, and then we'll compare those. And so I'll figure out the unit rates for each of the bagel prices. So $3.15 for 6 bagels works out to be 53 cents per bagel. And then in the second example, $4.15 for 8 bagels works out to be 52 cents per bagel. And so in comparing these by rereading the question, Joe thought that the first deal was going to be better, but it's actually the second deal that's better by 1 cent per bagel. This is an example of a question where you want to read the directions really closely. So better deal would imply that you're getting more for your money. In this final unit rate example, 3 athletes have been training for a race, and it gives you their 3 names and it gives you their 3 paces over different amounts of time. It wants you to predict who would win the race. And so to answer this question, you also want to figure out what their unit rates would be. In this example, whoever's number is bigger, right? It means they're going the fastest would be the one that would win the race. And so what's given to us is that Trisha goes 10 kilometers in 2.5 hours. And so when you divide those two numbers, you get that her rate is 4 kilometers per hour. When you do the same thing with Jason, Jason's going 7.5 kilometers in 2 hours. So Jason's going 3.75 kilometers per hour. And then the third person that's racing is Olga. It says that Olga averages 9.5 kilometers in 2.25 hours. You get 4.222. The 2 repeats. The person who would win the race, you would predict would be the person who's running at the fastest rate. And so out of these 3, Olga has the fastest time. And so Olga would be predicted to win the race running at the rates that the athletes are running at. All right, so in the next example here, we're going to look at conversion factors. So a conversion factor is a number that's used to change one set of units to another by multiplying or dividing. And so we're going to be changing between units. And so in this first example here, we're converting 40 miles per hour into feet per second. So you're going to start by writing down what you're given. And so if you start by going 40 miles per hour, notice that you want to change miles into feet. So there's one conversion that needs to happen. And then you want to change hours into seconds. It doesn't matter which one you take care of first. Sometimes you can do the conversion just using 1 or 2 conversion factors, and sometimes you need more. I'll start on this one by changing time. So notice that hour is in the bottom of the original ratio. When I'm going to turn hours into seconds, I don't necessarily know how many seconds are in an hour, but I know how many minutes are in an hour. That's a known fact. So in 1 hour, there are 60 minutes. I'm going to put 1 hour in the top, and I'm going to put 60 minutes in the bottom, because remember, when you multiply fractions, values that are diagonal from one another can cancel. So hours would cross out with hours. If I stopped right now and if I did top times top and bottom times bottom and divided those numbers, I would end up with my units being miles per minute. But I don't want it to be miles per minute. I want it to be feet per second. So I still have more things that I need to do. Another known fact is that in 1 minute, there are 60 seconds. And so that conversion factor will eliminate minute. Again, I would multiply the numbers in the top, multiply the numbers in the bottom, and then divide them. And so that would have me in miles per second, which is good because I want to have seconds, but I don't want it to be in miles per second. I want it to be in feet per second. So my last conversion factor that I'll need is to convert miles into feet. There are 5,280 feet. Miles crosses out with miles. They cross out diagonally even when the conversion factors aren't right next to each other. And so look at the units that you have left over for your answer. You have feet in the top and you have seconds in the bottom. And that's good because you wanted to convert it into feet per second. So to figure out how many feet per second it is, you're going to do top times top times top times top, and then you'll do bottom times bottom times bottom times bottom, and then you'll divide those two numbers. 58.6 feet per second, the 6 repeats. So you can indicate that there, or you could round it to 0.7. All right, in this next example, it's asking you to do the same thing. It just looks a little bit different. The information for each of the conversion factors is given to you in this chart. So you always start with the rate that's given to you and then see what you're trying to convert it into. We're trying to convert it into inches. So I'll need to convert meters into inches. Also trying to convert seconds into minutes. So we'll want to make sure that we create that conversion as well. Let's do time first on this one. So if I wanted to change seconds into minutes, I know that in 1 minute there are 60 seconds. And so if I stopped right now, I'd be in meters per minute, but I don't want to know meters. I want to know inches. So now I'm going to turn meters into inches. The table here is just supposed to help you with your conversions. So you started out with the one you're given. You can cross them off if you want as you go. And then 60 seconds in 1 minute. So now I need to turn meters into inches. And that conversion isn't given to me, but I can turn meters into centimeters, and then I see that turning centimeters into inches is one of the conversion factors that's given to me. So I know that in 1 meter, there are 100 centimeters, and so meters crosses out with meters, and then the conversion factor between inches and centimeters is also given to me. So in 1 inch, there are 2.54 centimeters. If I stopped right now, I would be in inches per minute, but I'm not trying to figure out inches per minute. I'm trying to figure out how many inches do they walk in a total of 3 minutes. So I'm actually going to need to use one more conversion factor here. Oh, I already used this one. I'm going to need to use one more conversion factor here, and it's that 3 minutes right here that's all by itself. So when I multiply by 3 minutes, this one doesn't have anything in the bottom, so you leave the bottom blank. When you multiply by 3 minutes, the minutes crosses out, and so if you look at what you have left over in terms of your units, you just have inches left over, which is good because that's the way the question was worded. It said how many inches. So you'll do top times top times top times top times top, and then you'll do bottom times bottom times bottom times bottom, and then you'll divide the numbers in the top, that product that you get, by the bottom. And so for this one, you end up with 70.9 inches. The answer for this one is not a rate. The answer for this one is just the inches measurement for the unit of measure because you're figuring how many inches do they go. All right, so this next one is a different topic. It asks you to figure out percent of a number. What is 25% of 16? So it helps you to start by recognizing that 25% is the same as 1/4. And again, there's a couple different ways you can go about this. Counting the boxes, you see that there are 16 boxes. So you're trying to color in 1 out of every 4 boxes. If you wanted to, you could color in 1, 1, 1, and then 1. And even though they're spread out, that would give you the answer to the question. So if you color in 1 out of every 4 boxes with a total of 16 boxes, you wind up with your answer being 4. And 4 is the correct answer for this question. However, it might also be helpful to think about it a different way. So another way that you could think about this is you could divide the shape itself into fourths. So if you broke it into 1, 2, 3, 4, these red lines are dividing the shape into groups of 4, but you're making 4 total groups. If it wants you to color in 1/4 of them, you would look at the picture. This would represent 1/4 of the total number of blocks. This would represent 1/4 of the total number of blocks, and so on. Not because there's 4 of them there, but because you're breaking the total into groups of 4. And then if you wanted to color in 1 out of those 4 blocks, you would color in all 4 of these guys that are over here in this first group, but just the first group. So again, out of all 16, there's 4 of them. Both ways are correct for thinking about the question, and both of them give you the correct answer of 4. All right, in this next example, you're baking cookies for a party. You have baked 90 cookies and have 3/4 the total number of cookies that you need. How many more cookies do you need to bake? So you've made 90 already, but you're not done. 90 represents 3/4 of the total number of cookies that you're trying to make in total. So you need to make more. A couple different ways you can think about this one. I'm going to present sort of a non-algebraic way. All right, so if you think about the cookies that you're trying to make being like a progress bar, right? When you get to the end of the progress bar, you would be done with all of your cookies. It says right now you've baked 90, and that's 3/4 of the amount you need to make. So if you start by splitting this into fourths, you've made 3/4 the total number that you need. And so right here, the 90 cookies that you've made already represent 1, 2, 3 fourths out of the total number of cookies that you need. So you need to make more cookies. If 90 represents 3/4, then 1/4 would be 30, another fourth would be another 30, another fourth would be another 30, because 90 divided by the 3 would mean that each 1/4 was 30. And so the 30 more cookies that you need to make for this box, that would represent the answer to the question, which is how many more cookies do you need to bake? You're going to be making a total of 120, but the 30 represents the 30 more that you need to make to finish to have there be enough. In this next example, there's a definition that's given of the multiplication principle. It says the multiplication principle is a basic counting principle. Stated simply, the multiplication principle says the idea that if there are A ways of doing one thing and B ways of doing another thing, then there are A times B ways of performing both actions. And so here in this first example, it says that a child is choosing between 4 different ice cream flavors, 3 different types of sauces, and 7 different topping options. And the question is, how many unique ice cream sundaes can they create? So 4 options for the first, and then 3 options for the second choice, and then 7 options for the last choice. And so you'd multiply those together to find out that there are 84 total possible ice cream sundaes that can be made. And so this next question is kind of a number crunching thing as well. An animal shelter takes in both dogs and cats. They presently have 45 dogs and 57 cats. Each dog eats 1.5 cans of food per day. Each cat eats 0.5 cans of food. We're assuming they eat the same kind of food. The food comes in cases of 24. Assuming no animals are adopted, how many cases of food would they need to feed the animals for 1 week? So you're starting out with 45 dogs and 57 cats. And then they eat different amounts of foods. So in terms of figuring out how many cans of food you would need for the week, you can make that adjustment. Let's see. So 45 dogs times 1.5 cans of food per day times the 7 days in the week would give you 472.5. And then 57 cats times the half a can of food that they eat per day times the 7 days in the week gives you a total of 199.5. So that gives you the number of cans of food that you would need to feed the dogs and the number of cans of food that you would need to feed the cats. So again, assuming that dogs and cats eat the same kind of food, you're going to take those two numbers and you would add them up. And by adding them, you would get 672. But that's the number of cans of food that you would need. And so it's important to go back and reread the question. The food comes in cases of 24, and they're trying to figure out how many cases of food you would need. And so 672 is the total number of cans, but then you would divide that by 24 cans per case. And so by doing that division, it works out to be exactly 28 cases of food. Sometimes when you're doing questions like these, you end up with a decimal answer. And so in that case, remember you would need to round up to the next number because you would need to have enough food to feed all the animals, even if it meant having a couple of cans left over. All right, here in this next example, it says the speed limit on a local highway is 65 miles per hour. You'll get a ticket if you are caught going 15 miles over or 20 miles under the speed limit. So the first part of the question wants you to figure out what is the range of speeds for which you would receive a speeding ticket. And so here to answer this one, you have to understand the type of inequality that you're looking for. So you would receive a speeding ticket if you were caught going 15 miles over the speeding limit. So you would receive a speeding ticket if you were caught going 80 miles per hour or greater than 80 miles per hour. You would also receive a speeding ticket if you were caught going 45 miles per hour or any less than 45 miles per hour. And so this or split inequality tells you the two ranges of speeds for which you would receive tickets. The next one says, what is the range of speeds for which you would not receive a speeding ticket? And so you would not receive a speeding ticket if you were going the speed limit or if you were going 20 miles under or anywhere up to 15 miles over. And so again, letting S stand for speed, you would not receive a speeding ticket if you were going anywhere in between 45 miles an hour and 80 miles per hour. In the last two parts on this one, you're giving examples of speeds that would and would not cause you to earn speeding tickets. So you just want to come up with speeds that are within those ranges. So for the first one, it says would cause you, and then for the second one, it said would not cause you. So let's see for the first one, if you are getting a speeding ticket, it would be anything greater than 80 miles per hour. So let's say like 100 miles per hour, and then anything that's less than 45. So let's say 30 miles per hour. Lots of correct answers for these questions. In example D, you would not get a speeding ticket if you were caught going, say, 50 miles per hour, or if you were caught going 70 miles per hour. So you're finding answers that come within the ranges. All right, moving on. So rational numbers can be expressed in the form of a ratio, P over Q, and Q does not equal 0. And numbers are irrational if it cannot be expressed as such a fraction. The definition goes on to say that rational numbers are finite and repeating decimals, and that irrational numbers are infinite and don't repeat when you write them as decimals. So here on the next example, it says to determine if the numbers below are rational or irrational. So we're going to go back to the definition to help us out with these. 1/2 is written as a fraction, and so that is a rational number. 0.34, it's a terminating decimal. It's a decimal that finishes, and so that makes it be a rational number. The square root of 2 is not a perfect square. If you type that into your calculator, it's a non-repeating, non-terminating decimal, and so that is a definition of an irrational number. Any square root that's not a perfect square is going to be irrational. On the next example for D, 11 over 4 is written as a fraction, so that is rational. Pi is an irrational number. It can be approximated as 3.14 or as 22 over 7, but those are just approximations, so pi is an irrational number. On the next one for F, that number finishes with a decimal that terminates, and so that's a rational number. On G, there's a square root, but you have to be careful because 25 is a perfect square, so the square root of 25 is the same as 5, and so that would be a rational number. And then lastly, this one down here is tricky. So the square root of 3 itself would be an irrational number. But notice that this one says the square root of 3 squared. So you want to remember that when you square something that's underneath the square root, the squared and the square root cancel each other out. And so what you would be left over with would just be regular 3 when you square the square root of 3. And so that is a rational number. Numbers that are consecutive are numbers that are adjacent to one another or next to one another. And then the second part of the definition that's given says that the definition of the word integers are the set of positive or negative whole numbers, including zero. So no fractions, no decimals. They're whole numbers, but they can be positive or negative. The first question says you have three consecutive integers, so three whole numbers that are right in a row, and it says when you add them up, you get 90. And so you're trying to figure out what those three numbers are. Let me point out that there are algebraic ways that you can answer this question, but for the sake of the notes today, we're going to use guess and check. So you want to start out by trying some numbers. Let's say you just randomly start out with 25, 26, and 27. So they're all whole numbers. They're all right in a row, and there are three of them. When I add those three numbers together, I get 78. But I wanted the numbers to add up to 90, so that means that those three numbers that I picked were too small. So let's say that you randomly pick some other numbers. Let's say you pick 32, 33, and 34. But when you add those three numbers up, you get 99, and so that's too large. You're trying to have them add up to 90. So it means the answer is somewhere in the middle. So you would use your calculator, you would try some other numbers, and you'll get that for these, the answer to the question is 29, 30, and 31. Because when you add those up, you want them to add up to 90, and the three of those numbers do add up to 90. So the three numbers, it says what are the three numbers? So the three numbers would be 29, 30, and 31. So the next question is similar, but it's just a little bit different because it says the sum of three consecutive odd integers is 219. And so you're going to skip count on this one. Remember, the numbers like 2, 4, 6, 8, 10, those are even integers, and odd numbers are the numbers in between. And so when you're picking numbers for this one, you just want to make sure that you don't pick any even numbers. They're still consecutive, but they're going to skip over one in a row. And so again, there's algebraic ways that you can do this problem, but for this question, make a note that we're going to use guess and check. If you started out with, let's say, 25, 27, and 29. So those are three integers, they're whole numbers, they're consecutive, they're odd numbers, so it skips the numbers in between, but those are three odd numbers in a row. If you add those three numbers up, you get 81, and so that's too small because remember, we're trying to have them sum or add up to give you 219, so those three numbers are too small. So maybe you'll try some bigger numbers. So let's say you try 41, 43, and 45. When you add those ones up, you get 129. So you're moving in the right direction, but remember, you're trying to get 219, so these are still too small. So then you jump, and let's say you try 77 and 79 and 81. And so those numbers add up to be 237, but you only want yours to add up to be 219. So these ones here are too large. And so then you try some other numbers, and finally you get the correct numbers are 71, 73, and 75. Those three numbers add up to give you 219, which is the total that you were looking for. But you want to be careful because you have to read the way the direction was given to you. It says what is the value of the smallest of the three integers. So when you're writing the answer to the question, the three numbers that work are 71, 73, and 75, but the answer that you'll give, the smallest number in that list is the number 71. All right, on this last page, comparing rates associated with costs. So it starts out by saying, suppose the cost of electricity in Nevada is this rate and the cost of electricity in New York is this rate, and you're trying to figure out the differences between the costs in the two states. So we're going to have to figure out these two rates separately. All right, so in Nevada, it's 11.8 cents per kilowatt hour, and in New York, it's 20.1 cents per kilowatt hour. And they want to know what's the difference when they consume 3,587. So I'll multiply both of these by 3,587. All right, so once you have those two values calculated, you're going to subtract them to find the difference. And so when you subtract them, you get 29,772.1 cents difference. But that's a really weird way to write the answer to the question. Normally when we'd be writing numbers like this, we did all of these calculations in cents. Remember, a cent is 1/100th of a dollar, and so it would make sense to divide this by the number 100 because this problem would mean more if you gave the answer in dollars. So when you divide it by 100, you move the decimal point 2 places to the left, and then when you give your answer to the question, you would round it to 2 decimal places. And so the answer for this question is the differences in electrical costs between the two states is going to be $297.72, again rounded to the nearest 2 decimal places. All right, and the final question, Chelsea has some money saved for a vacation. The vacation is going to cost a total of $2,400. It says she's putting $200 every week into her account to help pay, and she'll have enough money in 9 weeks. So if Chelsea saves $200 per week times the 9 week, that means that in that time she'll save $1,800, but she'll have $2,400 at the end of that 9 weeks, which means she started with some money in the account. So if I subtract $1,800 that she saved from the $2,400, it means that she starts with $600. There are $600 in the account to start. And so adjusting her savings rate, it says if she can save $300 per week instead of $200 per week, how many fewer weeks will it take her to save enough money for the vacation? And so to do that, I'm going to make a table. Again, this table is for that new rate where she's saving $300 per week. So she starts with $600, and then the numbers on the top represent the number of weeks. If she's saving $300 per week, and we're assuming she's not spending any money in the meantime, then it's going up by $300 each week. And so you would continue that pattern of adding 300. I won't keep writing it, but you'll continue that pattern. So after 1 week, she would have $900. After another week, she'd have $1,200, and then that pattern would continue. So you wouldn't need to continue it to the 7th week. It would stop right there after 6 weeks. And so based off of that information, she would have her $2,400 after 6 weeks, but we want to reread the question to make sure we answer it the right way. It says, how many fewer weeks would it take her to save enough money for the vacation? And so in the original example, it was taking her 9 weeks. In this example, it takes her 6 weeks. And so 9 minus 6 gives you the answer to the question that it would take her 3 weeks fewer. Or another way that you could say that is that she'd have the money 3 weeks sooner if she were able to save $300 per week instead of $200 per week towards her vacation.